Stan Gibilisco here with an explanation of how to properly and improperly connect batteries in parallel. This video is in response to a reader's query about some information in this book, Electricity Demystified, 2nd edition. He's referring to page 68. On this book I talk about voltage sources in parallel on page 68. Batteries in particular. Once in a while you will want to connect batteries in parallel. Now you probably know already that you can connect cells in series like this. Generally speaking, the shorter one is minus and the longer one is plus. I can never quite remember those. But suppose that you connect three 1.5 volt batteries in series, you're going to get a total, assuming that you connect them minus to plus, you're going to get a total that's the sum of the voltages, in this case 4.5 volts. You've probably done that if you have a flashlight. Most of them do that. But now suppose that we connect some batteries in parallel instead. Now, why would you ever want to do that? Well, if you connect identical cells or batteries in parallel, and this is a very important consideration, they must all be identical when you connect them in parallel. If you connect them in parallel, you're going to want the negative to go to the negative, and the positive to go to the positive, and they're connected like a ladder. Now suppose that we have three, say 6 volt batteries, and they're all identical, all three of them. We connect them in parallel like this, we're going to get 6 volts at the terminals of the combination. But we are going to be able to get 3 times as much current from this combination of parallel connected batteries as we would be able to get from any single battery all by itself, assuming that they're all identical and they're all brand new, none of them are worn out. They're all capable of delivering roughly the same amount of current each. Okay, fine. Well, on page 68, I go into a little bit of an explanation of why you need to connect them so that their polarities agree and what will happen if you do not do that. Suppose that you switch one of the batteries around by mistake so that you've connected them in parallel all right, but now you don't have the polarities correct. The first 2 are all right, but the second 2 are not. What you're going to get, in effect, these 2 batteries are going to fight with each other. They're going to create a current, if we consider the current as the electron flow from minus to plus, which is the usual way of doing it. We're going to get a circulating current, a vicious circle of current between these 2 batteries. They're going to quickly wear each other out. They're going to waste each other's energy. They're going to buck each other, in effect, fight each other, and if we get anything at the output here, we'll still get 6 volts, but we'll only get, this battery will be the only one that can contribute to the combination. And in effect, this short circuit, depending on what kind of batteries they are, might even interfere with the operation of that battery. So that's a bad mistake. to connect batteries in parallel and make a mistake with the polarity, if these were, well, these batteries are both going to get hot. They're going to get really hot. And if they were automotive batteries, the lead acid type, the acid would probably boil out. The batteries might even explode. It's not only a waste of energy to connect batteries improperly in parallel, but it's also potentially dangerous. So remember, when you connect batteries, if you connect batteries in series and you get one of them backwards, it's no big deal. I mean, you won't get the voltage that you want, but it isn't going to be a danger, and it isn't going to wear out any of the batteries in a hurry. But if you're going to connect batteries in parallel with the intention of getting more current or more power out of the combination, double check, triple check, make sure you've always got the polarity correct. Plus, all the plus terminals should be bound together to each other, and all the minus terminals should likewise be bound together to each other. Stan Gibilisco, signing off.